let's continue to the next question. It's about acceleration. It's mentioned here, acceleration is a vector quantity, and as we mentioned before about vector quantity, that is a vector with a direction, which is different from a scalar quantity, which is a quantity without direction. And now it's asked us to state what is meant by the term vector quantity. And you mentioned vector quantity is quantity that show the rate of change of something. So actually this is not accurate, okay? I think that maybe you try to define acceleration itself, and yes, acceleration itself by definition. Okay, so let's do the definition of acceleration again. Acceleration is the rate of change in, you mentioned there, in what? In something. So what is the something here? Over time. Um, if we are defining, then this one should be capitalized to make it into a sentence. So in physics, we have change can be symbolized by delta. It looks like a triangle, but it is pronounced as delta because it's a Greek letter. Do you remember what is the something here? Yeah, that's right. That's the velocity. Okay. So if you want to define acceleration, then acceleration equals to the rate of changes, rate over time mean divided by time, and that's the change in velocity. Okay, so this is the definition of acceleration. But here in this question, they didn't ask for, hey, define the acceleration, right? No, they asked for what? Vector quantity only. So how can we define vector quantity? Let's make a nice comparison between vector and scalar. So then next time if you got this question again, maybe they can also ask you, can you state what is meant by the term scalar quantity? So we can answer this question as well. So first they are on quantities, okay? What does it mean by quantity? Quantity means that you can measure it. So it's unmeasurable. And what does it mean by measurable? It means that you can express it in number, you know, in a number, in some numerical values. If you don't want to say number, then you can say that that's the numerical values, okay? First, that the first thing is measurable. But in physics, we don't just measure things, but we also have the unit to go with it. So measurable here also is read in number, and it's also have it on unit. And with the unit here, it can help us to distinguish between different quantities, okay? And sometimes it can also help us to derive the equation again, like what we did above here, right? The second thing is that we want to check, because it's a quantity already, it can be measurable. So this numerical values here is also called the magnitude. What does it mean by magnitude? Just like how big the size of the quantity. For example, if we say that I'm traveling at the speed 5 meter per second, compared to another one that travel at a speed like 100 meter per second. Can you imagine the difference, right? You just like blink your eyes for 1 second, and then you can see someone have traveled 5 meters already. But this one is just like you blink just a little, just 1 second, and then that person have moved like 100 meters, which is really fast already. And you know what is the highest speed right now? Of which object? Yes, that the 300 million meter per second. Do you know whose speed is that? That's light. This is the absolute, the greatest speed so far in this world we know up to this point. Okay, maybe a new knowledge of speed can tell us more later in the future. I'm not sure because science is keep evolving over time. But this is the rate of speed so far. Okay, so you can see those values here is actually tell us how big of that thing, the size of that thing. So that is the magnitude. Okay, so does the vector quantity have magnitude? Yes, right? Like for this one, the air resistance force is I have direction, but it also has some magnitude here with like 760 Newton. See that? So 760 is like the magnitude of this one. Or like the accelerations here, 0.95. That's also the magnitude measured in meter per second square. So vector should have magnitude and scalar should have magnitude as well. That's the only thing difference between vector quantity and scalar is that vector has yes direction, but scalar no. Okay, and direction basically, in order to define direction, is like an arrow. You should have a starting point. A starting point here. This one. And you also should have the ending points here, right? Initial point, final point, or we also call this one is like the head of the arrow of the vector. Just imagine like you can imagine the vector will just like go this way, right? So this is like the head of it, and this is the back, or we can like call it like the tail, because in order for an arrow to fly in the air, it should have a tail with all the feathers, right? Just like a bird. So we call this one as like the tail, and this is the head of a vector. So basically I want to make sure that we can distinguish between a vector quantities and a scalar quantities, and the difference is that magnitude, yes, both of them have its own quantities, is measurable, can be expressed in some number, in some values with a unit. Direction vector, yes, but scalar, no, no, no. Okay, so then vector also can be expressed with an arrow, by an arrow with a head and a tail. And if you have some, for example, if something travel this much, like 5 meter per second, and you want to express it, okay, if it's just a one cell here, that should be like 5 meter per second. So if you draw another arrows in scale, okay, in scale with this one, then if it's twice the length, it should be, this is like 10 meter per second. Makes sense, right? And if it's like 20 meter per second, it should be what? This is 10, 20, 30, 40, 50. You see that? And then 60, 70, 80, 90, and then 100. Oh, can I? Okay, so it's somewhere here. Okay, can you see how difference between these factors here? Right. Let me count again. I want to show you the difference here. So this one is a 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 is here. You see that? The length. Oops, sorry. The length. Misspelling. Okay. The length of this arrow will represent for the magnitude of it. So if you have this one like 5 with one cell, then 2 cells, 2 square will be 10. Then this one should be like 20 to express the length of a vector. Okay, this is a vector that have the magnitude as 100 meter per second. See that? Compared to this one, this little one here, it's just like 5 meter per second. So that's magnitude. Okay, and like if you have the 5 towards to the right like this, like to the east, right, it will be different if you have someone travel at 5 meter per second to the north, right? Or if someone travel this way to the west, or someone travel this way to the south. So you can see direction matter as well. So in short, vector quantity is a quantity with magnitude and direction. Okay, or you can just say a vector quantity has magnitude and direction. But this is the best way to say it. Make sense? Okay, please let me know if you have any question about this part. Thank you.